Let's look at the distributive property of exponents. Distributive property of exponents. What do we mean by the distributive property of exponents? If we have two terms that are being multiplied, let's say we have 2 times x here, and if the whole thing 2 times x is being raised to a power, say 3, how can we simplify this? Well, we can say that 2 times x to the third power is the same as 2 times x times 2 times x times 2 times x. And these are all being multiplied together. So we can actually switch some of the orders here because multiplication is commutative. Let's put all the 2's together and all the x's together. We have a total of 3 2's and 3 x's. Now, the 3 2's we have here can be simplified to 2 cubed, and the 3 x's we have here can be simplified to x cubed. Now, if you look at our original question, 2 times x raised to the third power, this now became 2 cubed times x cubed. So the exponent of 3 was distributed to all of the terms inside that were being multiplied. And we can see that this is true for other terms as well. Let's say we have x times y, and we're squaring this. That is going to equal x times y times x times y. Again, we can switch the order. X times y times y. That is going to equal x squared times y squared. And again, the exponent was distributed to both x and y inside. So this leads to a general rule. If we have a times b, and that is being raised to some power, let's call it n, and that is going to equal a to the power of n times b to the power of n. So this is called the distributive property of exponents. Now, there's another part to this property. Let's say we have, instead of a product of two terms, we have a quotient. Let's clear our screen here. So you have 2 over x this time, and that is being raised to the third power. How can you simplify this? Well, we can rewrite this as 2 over x times 2 over x times 2 over x. And we have 3 2's on the top, so that's going to be 2 to the power of 3. And 3 2's on the bottom, or sorry, 3 x's on the bottom, that's going to be x to the power of 3. And again, if you compare this to our original question, you can see that the exponent of 3 was being distributed to both the numerator and the denominator. So again, this leads to the second part of the property, which says if we have a quotient, a over b, and we're raising this to a power, that is going to equal a to the power of n over b to the power of n. So the distributive property for exponents can be summarized with these two things. We have the quotient part here and the product part here. A to the power of n times b to the power of n. Now, when applying this property, we need to be careful of where the parentheses is. For example, especially when we're dealing with negative numbers, we have negative 2 to the power of 4. What would this equal? Negative 2 to the power of 4 would be negative 2 times negative 2 times negative 2 times negative 2. And negative 2 times negative 2 here would be positive 4. And again, the negative 2 times negative 2 would be positive 4. And multiplying positive 4 times positive 4 is going to equal 16. We can do it this way, or we can think of this as product of negative 1 and 2. That is being raised to the fourth power. and the 4 is being distributed, the power of 4 is being distributed to both the -1 and 2. So that is going to equal -1 to the 4th power times 2 to the 4th power. And of course, -1 to the 4th power is just going to equal 1 because 4 is an even number. And 2 to the 4th power is going to equal 16. So that is also going to give us 16. However, if the negative sign is outside of the parentheses like this, our answer is going to be different. The power of 4 is only being applied to the 2 here. It's not being applied to the negative sign in the front. So when we simplify this, we have to leave the negative outside, do the 2 to the 4th power first, and then apply the negative last. So that is going to equal -16. So be careful when you are calculating with negative signs and parentheses. You have to be careful if the negative sign is inside the parentheses or if it's outside of the parentheses. If it is inside, you have to apply the power to both the negative sign and the number. If it is outside, leave the negative sign outside and apply the negative sign last after you're finished calculating the number.